The broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome to this TIER webinar session. My name is Burnett Blake, a TIER project coordinator for tiered intervention using evidence-based research. Today we have with us Dr. Sarah Powell. She is our fearless leader um, as our principal investigator for the network here at the University of Texas. And today she'll be presenting on mathematics intervention within remote learning settings or environments. For those of you that are not aware, TIER is a TEA-funded network under their technical assistance network funds. And so our sole purpose is to provide intervention best practices for those educators to provide to our young minds within the state of Texas. In your upper right screen, you will see a way you can raise your hand or ask a question. So during our session, if you have any questions, please feel free to add those to our questions box. And as we go along, we will be able to answer those questions throughout the presentation today. Without any further ado, Dr. Sarah Powell, we have right now approximately a few people still coming in. So do you have anything that you want to express prior to, or are you ready to go for
I
our?
think we're ready to go.
All right,
Yeah.
awesome.
All right. All right. Thank you so much, Burnett. Good morning, everyone. Welcome to this webinar. Today, we're going to be talking about interventions within remote learning environments. And our focus today is mathematics. So as Burnett said, TIER is the Tiered Interventions Using Evidence-Based Research. This is one of the 9 networks funded by the Texas Education Agency. And our network focuses on multi-tiered systems of support. And so because we know that in remote environments, we have a lot of students that are going to need assistance and require help within multi-tiered systems of supports, an MTSS framework, I will say, we're going to focus on the mathematics ideas around MTSS and what students are going to require in remote learning environments. And as Burnett said, my name is Sarah Powell. I am an associate professor at the University of Texas at Austin, and I focus all on math. So I do a lot of research about students who learn mathematics and some of the difficulties those students might face. And I also work a lot with teachers. And so a lot of the things that I'm going to talk about today have come about based on conversations with teachers over the last 6 months. Also, things that we're going to talk about today come through my own experiences providing remote learning over the last 6 months. Since March 17th, I've been teaching mathematics twice a week to my twin nephews who live in Massachusetts. I did this all through the spring semester, all through the summer, and we are going to continue through June of 2021. So these are some snapshots of some of the things that I've been doing as I've been working with them. It's been really fun and also very challenging. And so I'm going to share some of the things that I've learned from working with them with all of you today. And also, as we think about remote learning, I want us to think not just about remote learning, but about strong instructional practices across all settings. This is a snapshot from a slide from the Texas Education Agency about high quality instructional materials. And if you'll look over on the left-hand side in the kind of the green dashed rectangle, it'll say that TA recommends that instructional materials be designed for both use on campus and use in remote settings. So this webinar is not only about remote tips and tricks, but this webinar is about what are the strong instructional practices in mathematics that we should be thinking about, not only in remote settings, but also in on-campus settings. Because I think probably most of you are expecting or have already started in one setting. Maybe you're providing virtual learning right now, and then you are going to move into in-person instruction. I can also imagine that some of us that are starting with in-person instruction might move to remote learning at some point during the school year. So everything we're going to talk about today are just strong evidence-based practices for mathematics intervention that should be used both in-person on-campus settings and in remote virtual settings. So let's go ahead and get started. Our objectives today, we're going to quickly review MTSS, and then we're going to deep dive into considerations for remote learning. Again, our focus today is on mathematics. We're going to talk a lot about the design of the intervention as well as the delivery of intervention. And then at the end, I've put together 10 tips for remote learning, and I also hope that you will add to this list so we can have a longer list than 10 of things we need to consider when providing remote mathematics learning to students. So with the TIER project, we're focused on the MTSS framework. And just as a quick review, an MTSS framework typically involves three different components. We have universal intervention, targeted intervention, and intensive intervention. And universal intervention, this would be mathematics instruction that's really designed for all students, and it occurs in the general education classroom. And all of the things that we're talking about today should occur within universal instruction, but our focus is really going to be on targeted intervention and intensive intervention. So with targeted intervention could also be called secondary prevention or tier two. This is going to be designed for students that are experiencing difficulty with mathematics. And so a lot of the strategies we will talk about are going to be those that should kick off targeted intervention, which typically involves 20% of students, and then should be used continuously through intensive intervention, which typically involves only about 5% of students. So again, as we talk about these mathematics strategies today, they should be employed in universal intervention, but are absolutely necessary to use within targeted intervention and intensive intervention. So let's deep dive into our topic for today, thinking about remote learning in mathematics. Now, when we are designing mathematics intervention, there are two essential components that need to be considered. We can't really think about mathematics intervention without thinking about these two things. The first is the design of the mathematics intervention. And then the second, once we've designed it, is the delivery of the mathematics intervention. Let's first focus on the design. When we think about the design of a mathematics intervention, there's three things that I think are really essential. And I don't think they're really essential. I actually know they are because we have to think about these things as we design math interventions to use in schools. The first is going to be to determine critical content. The second is to identify evidence-based practices. And then the third is going to be to create the instructional platform. And over the next few slides, I'll talk about each of these in some detail. So first, let's focus on determining the critical content. So I want us to think about mathematics as a continuum of learning. So here I have this line at the bottom, and I can think about this starting on the left-hand side as easier mathematics content and moving to the right-hand side as more difficult mathematics content. And when you are thinking, I have to provide mathematics intervention to this student or this group of students, the first thing that you ever need to think about is, well, what is the critical content that I'm going to need to include in the mathematics intervention? And you can do that by thinking, okay, here's where my student or students need to be on their mathematics continuum. So if you're a first grade teacher, you might have that green arrow pointing at maybe the end of a first grade year. If you're a seventh grade teacher, you might have that green arrow pointing at the end of a seventh grade year or the end of seventh grade content. But you're thinking about providing intervention to students because this is where your students are. So maybe you have one student or several students. And it's this area in between the red arrow and the green arrow. That's going to be the area where we really want to focus a lot of our content during the intervention. So we have to go back and fill in some foundational gaps while continuing to move the students forward to meet grade level expectations. So you really have to think about, well, where are your students now? And where do your students need to be? And then think about the content that falls between those two arrows. And then that's going to drive all of the decision making that you're going to make from this point forward. It's going to help you decide which interventions you use, which strategies you use, which manipulatives you might use, as well as any assessments that you might use. It's all going to help you gauge how students move from the red arrow to the green arrow. Now I'm going to give you an example from word problem solving. I choose word problem solving because it's an absolute essential skill for students to develop across the grade levels. And so if I think of my mathematics continuum here and I think about word problem solving, first students solve addition and subtraction word problems within 5 or 10, and then they move on to doing that within 20, and then doing that within 100. And then we introduce multiplication and division word problems, and then we solve word problems with all four operations. And then we do word problems with addition and subtraction of fractions and multiplication and division of fractions. And then we move on with solving word problems with all four operations with rational numbers. And then we solve word problems with equations. And so if I think about, well, here's where my student needs to be, but here's about where my student is, it's going to be this content really focusing on these three purple rectangles between the red arrow and the green arrow. That's going to drive the instructional decision making that I make about my mathematics intervention. Now I'm going to give an example where I want you to focus on those three rectangles between the red arrow and the green arrow. And I'm now going to dig a little bit deeper within my mathematics continuum. So right now, I imagine my students are pretty comfortable with solving addition and subtraction word problems within 100, but we want to get them to solving multiplication and division word problems. That's over there on the right-hand side of my screen. But when I'm thinking about the critical content, and if I want my students to be stronger word problem solvers, there's a lot more than just word problem solving that goes into this. So when I think about, I might need to make sure that students understand addition and subtraction strategies and multiplication and division strategies. I may need to bring in some ideas around place value, making sure that students understand what multi-digit numbers are and what they represent. And I also might want to bring in some ideas related to fluency. We know that fluency makes everything in mathematics that much easier. So I may want to make sure that my students have strong fluency skill, because then that would help make word problem solving a little bit easier. And as I fill these in on my mathematics continuum, I now have a much richer and deeper idea of the critical content that needs to be included in my planning for the mathematics intervention. So I think about, well, we're starting where the red arrow is or thereabouts. And as I move students from hopefully the red arrow toward the green arrow, if I'm moving them along on the mathematics continuum of learning, I'm going to include instruction around fluency. I'm going to include instruction around what do the operations mean. We're going to include instruction around place value, and then we're also going to include instruction around word problem solving. So before you ever start doing intervention with students, it's really important to be reflective of the critical content that needs to be a part of your mathematics intervention. And this is one way of doing that. So we just focused on determining the critical content, and now I'd like to focus on, well, identifying the evidence-based practices that can be used to teach that critical content. So the term evidence-based practice is an umbrella term. So I put an umbrella up here so it's easy to remember that. And it encompasses several different terms that you hear a lot in education. So one type of evidence-based practice is an evidence-based intervention. This is a packaged intervention that you can purchase. Sometimes it might come with like in a manual with paper. A lot of times it's going to come via technology, but it's all put together for you. Oftentimes you start on day one and you go through day 60 or day 180, but everything is prepared for you. It's an evidence-based intervention that has shown evidence, and that mean when I say evidence, that means it works for most students most of the time. Now, another type of evidence-based practice is an evidence-based strategy. An evidence-based strategy is something that's often not packaged or cannot be packaged. So an example of evidence and evidence-based strategy in mathematics is the use of manipulatives. There's a lot of different studies that suggest that using hands-on tools is helpful for increasing the mathematics knowledge of students that experience difficulty with mathematics. Another evidence-based strategy is using explicit instruction. So explicit instruction, that's not actually a package that you buy, but it's a strategy that you use. Other evidence-based strategies include building fluency. That's a strong evidence-based strategy as well. Another type of evidence-based practice might be something that's a promising practice. Maybe there have been a few studies that have shown, well, this shows promise for increasing the the mathematics knowledge of students, but maybe it hasn't accrued a strong evidence-based practice yet. But when you are thinking about, well, how am I going to teach this mathematics that's on my critical content timeline, you want to choose an evidence-based intervention. You maybe want to pair that with the use of evidence-based strategies, or when an evidence-based intervention is not available, rely on a set of evidence-based strategies, or you could also rely on promising practices. But you'll see over here on the right-hand side that we do not want to use things that have no evidence or even negative evidence. There are a few interventions out there that have actually shown negative outcomes for students experiencing mathematics difficulty, and we definitely do not want to choose those. So we've focused on our critical content, and then we want to think about evidence-based practices to deliver and teach that content. So some of my favorite websites for figuring out evidence-based practices are the following. So Evidence for ESSA, this is a good website to use. You can see if you go to the front page of this, you can click on math programs. This website has a mix of universal intervention math programs as well as targeted intervention programs. So it's a good start if you're thinking about, well, what should I be doing in universal intervention as well as what should I be doing within targeted intervention. You could also look at the website Ed Reports. If you go to compare materials, you can see all of the math comparisons that they have produced. You will get very disappointed very quickly on edreports.org because there are a lot of programs out there that have limited evidence. One of my favorite websites is the intensiveintervention.org. This is put on by the National Center on Intensive Intervention. If you go to implementation support and intervention materials, there are a lot of different mathematics materials that you can access, and I'll share a few of my favorites at the end. And then you can also go to the What Works Clearinghouse. This is a really great resource, especially for universal intervention mathematics materials. They have a little bit in terms of targeted and intensive materials. But one of the best things about the What Works Clearinghouse is that they have put together what they call practice guides. This is from the practice guide titled Assisting Students That Struggle with Mathematics, Response to Intervention for Elementary and Middle School. This practice guide came out in 2009. They are redoing it right now. And to no surprise, there's really not a lot of changes to the practice guide. The evidence is still very strong that these are the things that we should be doing when we are providing instruction to students that experience difficulty with mathematics. And in this practice guide, there are 5 areas that have moderate to strong evidence. And we are going to talk about all of these today in this webinar. So first is, well, screening students that have mathematics difficulty. You've likely already done that within your MTSS framework. If you haven't done that, make sure you are doing it. But we're going to focus on number 3, using explicit instruction. Number 4, thinking about appropriate word problem solving instruction. Number 5, using visual representations. And number 6, building fluency. So in thinking about the design of our mathematics intervention, we've determined the critical content and then identified the evidence-based practices that we will use to teach that critical content. And then we take all of that information and we create what I call the instructional platform. This is the jumping off point for providing your targeted or intensive mathematics intervention. And taking those things that the What Works Clearinghouse says are important, And not only do they say they're important, we really know from educational research that these things are essential within targeted and intensive intervention. We build our instructional platform. And that should include the following. In terms of the delivery of our instruction, we should provide explicit instruction paired with strong, precise mathematical language and the use of multiple representations. And then we should also build fluency and provide problem solving instruction. So if we are thinking about, well, how do I start putting together my mathematics intervention? These 5 things are going to be your essential components for starting. So we just talked about the design of the mathematics intervention, which includes a reflection of what is the critical content that I need to teach, what are the evidence-based practices that I can use to teach that critical content, and then how can I put together the instructional platform. So now I want to move over to the delivery of your mathematics intervention. And we're going to start with our instructional platform and think about, well, how do we deliver that critical content through the use of evidence-based practices for students that experience math difficulty? So pretty briefly, I'm going to go over these 5 components. So first is that we absolutely need to use explicit instruction. Explicit instruction is a wonderful combination of modeling and practice. When we talk about modeling, that should start off with a clear explanation. So you should state the goals and really the outcome of what you're working on with the student in mathematics. And then that clear explanation should include step-by-step modeling of how to solve a specific type of math problem. And as you are doing that, make sure that you have strong planned examples. So you might use just regular examples or regular problems. You might use worked examples from pseudo students to show, well, how did this work and how did this not work? And you could also bring in non-examples. But modeling is led by you, the teacher, and it's a clear explanation of how to solve a problem paired with examples that are going to help the student understand mathematics better. And then with that modeling, we pair that with practice. And there are different types of practice that students should engage in. One is guided practice. Guided practice is when students are working with a teacher to focus on a specific type of math activity or math problem. In guided practice, maybe you're doing a problem and the students are doing the problem with you. Maybe you start the problem with the student and then they finish the problem on their own. But the idea here is that you're providing scaffolded support for the students so that they aren't just left to their own devices, but they are there and talking with you about the mathematics. You're asking them questions and you're engaging in dialogue with them about the math that they need practice on. But then we can also engage students in independent practice. So this is where students practice more independently. You might still be there to provide feedback, or you might provide feedback after the fact. But the idea is that with practice is that students aren't just practicing on their own, but often they're practicing with you. Now you'll notice in terms of explicit instruction, we have this orange rectangle at the bottom that says supports. And so during both modeling and practice, we need to make sure that we're supporting students adequately. So are you asking the right questions? Are you getting students to elicit frequent responses? My typical rule of thumb is that I check in with students every 30 to 60 seconds. I mean, that's kind of the maximum time frame that goes by. But really, if you haven't checked in or haven't asked a student a question or have had them do something in 60 seconds, you're losing their attention and they're paying less attention to the mathematics. Are you providing immediate feedback to students? Is this feedback affirmative? Is this feedback corrective? And then are you moving the lesson along? Many times we try to slow stuff down so that students really get time to explore and understand the mathematics. But we've also learned that by moving at a brisk pace, like, oh, here's our next problem, and then this is what we're going to do next, that keeps students' attention high. And then as students are paying more attention, they're learning more mathematics. So explicit instruction is really the foundation for any instruction that you are going to provide within your targeted intervention or your intensive intervention. And this is true both in person or in remote environments. Now, beyond explicit instruction, we want to make sure that we're using strong mathematical language. Students have to listen a lot to mathematics and understand all of the words and sentences and paragraphs that are being expressed to them. Students have to speak a lot in mathematics, so responding to questions, engaging in dialogue, talking to peers, talking to their teacher. Students have to read a lot in mathematics. So this might be reading in a textbook, this might be reading text that's on a screen. And sometimes students have to write in mathematics. And all of this involves an understanding of mathematics vocabulary. So within your targeted intervention and your intensive intervention, you need to make sure that students understand the vocabulary of mathematics. So you may need to provide mathematics, explicit mathematics instruction, but you may also need to check in with students and say, well, what is the numerator? Can you tell me what you know about a numerator? What does it mean when I have 0 pairs? Can you show me what a 0 pair means? So these are all some of the things that you need to think about in terms of your language and your students' language, because if students aren't adequately processing the language of mathematics, it's going to be very difficult to learn the language of mathematics. Now, I know I'm going very fast because I don't have a lot of time this morning, but I'm going to pause for about 20 seconds because I need to get a drink of water. And then we are going to continue with our third essential component in terms of the delivery of instruction. All right, so we are going to go ahead and continue. So right now we're thinking about how do we deliver really good mathematics intervention to students within targeted intervention and intensive intervention. And as I said at the beginning, these are also the things we should be doing within universal intervention. So really, anytime we're teaching math, we should be doing these things. But our focus for this webinar today is within targeted and intensive intervention. So I'm going to emphasize that quite a bit. The third thing that we need to be thinking about when we are providing intervention to students is the use of multiple representations. When we think about multiple representations, this is often described as the concrete pictorial abstract model. A lot of you might know the language concrete representational abstract model, and some people use concrete semi-concrete abstract to describe this use of multiple representations. I'll just describe each of these briefly. The concrete means using hands-on tools to help students understand math concepts and procedures. These are hands-on things that students can touch and move around. You can buy a tremendous number of concrete tools. There's also lots of things around the house that you can use for hands-on manipulatives for mathematics. The pictorial are pictures of mathematics. These may be two-dimensional images on a worksheet or on your computer screen. This also is where we can capture virtual manipulatives. There's pretty much a virtual manipulative for every hands-on manipulative these days. And so you can use those pictorial images to help students understand math concepts and procedures. And then understanding mathematics in the abstract is understanding the numbers and symbols and words that describe mathematics. And as you will notice on my diagram on the left-hand side, there's overlap among all three of these multiple representations. And I always like to put abstract kind of on the top of the concrete and the pictorial, because I would argue that when you are teaching mathematics, the abstract should always be present. So if you are showing students how to multiply numbers, you should have that problem on the screen or on a worksheet or on the page or on your document camera, whatever it might be. So I think that the abstract should really always be there so students understand how to connect the concrete and the pictorial to those abstract representations of mathematics. On the right-hand side, I have a few examples of some multiple representations. These are actually all virtual examples. I thought those would be important to bring in here today. At the top is an example of virtual Cuisenaire rods. Cuisenaire rods are great for learning to count and adding and subtracting. You can use them really well for multiplication. They're also a wonderful fractions tool and also very good for decimals. So they have a lot of staying power along the continuum of mathematics learning. In the middle, you see a digital geoboard. This is really awesome for geometry and measurement. Also really good for fractions. You could do some really cool stuff with the area model of fractions on a geoboard. And at the bottom is an example of the virtual manipulatives related to algebra tiles. These are great in the middle school and high school grades to help students understand how to set up equations and what it means to maybe multiply x minus 1 times x plus 2. You can actually show all of that visually, which is very, very cool. So there's lots of different ways to bring in multiple representations. And the whole idea around multiple representations is to help students see the mathematics and work with the mathematics in different ways than just always doing mathematics with numbers and symbols. Beyond the multiple representations, we want to help students build fluency. Fluency we often think about as math fact fluency. With our math facts for addition, subtraction, multiplication, and division, there are 390 separate math facts. That's a lot. And if we think that we rely on those facts to then help us with multi-digit computation and to really help us with everything else in mathematics, our facts will be used when we're solving problems related to geometry, measurement, statistics, probability, algebra. So if students have not a strong background with math fluency, it's something that if we build fluency, it's going to help students in that grade level and then in subsequent grade levels. Math fluency is really the gift that keeps on giving. When we think about fluency building, we can think about doing this pretty briefly. I'd say 1 to 2 minutes a day. It might be a little bit more than that, but you really don't have to spend 20 minutes a day building fluency. But when I say a day, whenever you are providing intervention, you should be doing some type of fluency practice. Now, beyond math facts, if you have a student that shows that they have proficiency with their 390 math facts, you might want to build fluency with computation. So how efficiently do students solve a problem like 26 plus 19 or 32 times 5? Beyond that, you might want to think about fluency and how well students find common denominators between a set of two fractions, or how well students add and subtract problems with positive and negative integers, or how well they multiply and divide problems with positive and negative integers. And then fluency can be carried forward into algebra. How efficiently do you solve a problem like x plus 2 equals negative 5? So really fluency is all around us. It's not just bound to the 390 math facts, but that's where we should start. And then as students develop proficiency with the math facts, we can move beyond that and continue with our fluency building. And then our fifth thing that's really important to think about is providing strong problem solving instruction. In the state of Texas, as well as every other state in the United States, students show their math competency through solving word problems. So if we aren't providing really good word problems instruction, and if we aren't providing that instruction regularly, we are failing our students. This slide is just one slide about word problem instruction. Usually I talk about word problem instruction for about 6 hours, so it's hard to get this down to one slide, but I will say two things about word problem instruction, and then at the end I'll point you to a resource where you can learn a lot more about this. The first is on the left-hand side. Word problem instruction must include an attack strategy that students can use when they see a word problem. Here I've put one of the attack strategies that we use regularly in our mathematics interventions, but there are many others out there. We like the UPS check strategy, which means you understand a problem by reading it, you plan, so how will you solve the problem? You solve the problem, and then you go back and check your work. Other really popular attack strategies in the state of Texas include cubes. If you are going to use the cubes attack strategy, please turn that into R cubes, read the problem first, and then use the cube strategy. Other attack strategies include ridges or star or ride. There are at least 20 attack strategies out there, but you and your students only need to use one. Now on the right-hand side is a representation of the different schemas or structures that we see students regularly faced with solving when it comes to word problems. So these structures start out in the early elementary grades. So in kindergarten, students will see the structures of total, difference, change. Around third grade, students will be introduced to the equal group schema and the comparison schema. And then in middle school, students will be introduced to the ratios or proportions schema. And these six schemas or structures are really very common. So if we teach students to recognize these schemas, then they can say, oh, this is a difference problem. I know how to solve a difference problem. Or this is a comparison story. I know how to solve this. So in a total story, students have parts that are put together for a total. In a difference story, there are two amounts that are compared for a difference. In a change story, there's one amount that increases or decreases. In an equal group story, there are groups with an equal number in each group. In a comparison story, there's a set that's compared a number of times. And then in a ratios or proportion story, you are comparing quantities. So if this is to that, then this is to that. And I'm sure that that was a lot of information on one slide. And again, I'll point you to a resource that has a lot more about strong word problem instruction. I'll do that at the end of this presentation. So as we put these together, when we think about our delivery, so this is our instructional platform, this is our jumping off point for delivering mathematics intervention, we need to start with explicit instruction, pair that with the use of strong, precise math language, maybe even providing explicit vocabulary instruction. We need to pair those two things with the use of multiple representations. So having students use hands-on tools, virtual manipulatives, drawings, graphic organizers to understand the abstract form of mathematics. And then every day we provide intervention, we should be helping students build fluency, and we should be providing problem-solving instruction. So those five right there are going to get us off to a really good start with providing targeted intervention and or intensive intervention. Now I want to move to some tips and ideas for remote learning. Now I leave these toward the end because I think at the beginning it was really important to set up, well, what should our math intervention look like? And again, remember, this is going to carry over from in-person environments to remote environments, or carry over from remote environments to in-person environments. But these suggestions are more just for remote learning, but you also might want to use some of these in the in-person learning as well. So the first one, this should look kind of familiar, is to plan your design and delivery. So I think this is going to be really important, and I know I was working with a lot of teachers in the spring on this, is okay, if I'm going to be providing remote learning, what needs to be included in the remote learning? You might not be meeting with your students as often. Your students might have missed out on instruction for 4 or 8 or 12 weeks, or maybe even more. So you really have to focus on the critical content. Where are your students and where do they need to be? And then what's the absolute critical content that you need to address on this mathematics continuum of learning? Probably, as you already know, we can't use our regular scope and sequences because they may not be applicable right now. You might have to go back and reteach a lot of instruction from the third grade year for a fourth grade year. So you can't just use your fourth grade regular scope and sequence. So the first thing in remote learning is you really need to think about the continuum of math learning, the critical content, and what's going to be included in your remote learning. And then as you determine that critical content, I hope that you'll think about that instructional platform. So how are you going to design the platform with explicit instruction, precise language, multiple representations, as well as building fluency and problem solving instruction. We can't leave those things behind just because we've moved to remote learning. Our second tip is to schedule remote learning so that it occurs regularly. The typical suggestion for targeted or intensive intervention is 3 to 5 times a week. For targeted intervention, around 3 times a week. For intensive intervention, it should be daily or 5 times a week. The most that students usually can do in a session or at least have attention to do in a session is 20 to 30 minutes, although there are some students in the older grades that might do sessions up to 45 minutes. This is an example from my calendar. Again, I said I've been providing intervention to my nephews. Here's an example of 3 times a week. I have one of my nephews from 9 to 9:30 and then the other nephew from 9:30 to 10. So as you guessed it, I'm going to be teaching math tomorrow morning at 9 a.m. Each session should be structured the same. So this is both in in-person environments and remote environments, but students really thrive on structure. So you know when you log on to your Zoom or your Google Meet, here's what's going to happen today. So a really strong structure would be using a fluency warm-up, so something related to either fact fluency or computational efficiency at the beginning, and then really digging into the content. So you might be doing, if it's a review, you might be just doing a little bit of modeling and a lot more of guided practice. If this is something new that your students haven't learned before, you might be doing 10 minutes of modeling and maybe 10 minutes of guided practice. And then having review at the end. I've actually been doing review where my nephews are doing independent practice and then they're showing me their work and I'm providing feedback on that while we are still on the Zoom call. So this is just a standard structure. This is not one that you absolutely have to follow, but it's just a suggested idea that every session should have the same structure so that you know how to plan and that students know what to expect. The fourth tip for remote learning, and this is a little bit strange, but I've really learned to rely on no materials at the student's home, not even sometimes a pencil. And I hope some of you laugh at that because I will ask, like, is there a pencil around you? And there is no pencil to be found and there's no paper to be found. And so while I have sent a lot of hands-on tools to my nephews, even then, like one day I said, hey, could you find those 2-color counters? And after 2 minutes of looking around, they couldn't find them. And I'm like, okay, let's not waste time. We'll draw 2-color counters. So I think this suggestion is, even though you have all these beautiful and grand plans for, using these materials that are in the student's home, also figure out how you're going to adapt very quickly when those are not available. So this is just an example from Zoom has a whiteboard. Hopefully a lot of you are already using that. And so quickly I can draw things. I wanted them to use fraction tiles. Those aren't available. So let's just go ahead and draw our fraction tiles for today. The fifth suggestion is to really prepare a lot of work and presentations and use a lot of sharing of your screen. On the left is an example of the magic squares. Here you have the numbers on the right, so 6, 2, 1, 3, 3, 3, and 2 and 9. And those will all fit into this grid where I can find, well, which 2 numbers add to 18? I'll put those in the far right-hand column. Which 2 other numbers add to 18? I'll put those in the bottom row. And then I can place in the other numbers so that they will add to the numbers at the bottom in the bottom row or on the right-hand column. Magic squares are a really great way to practice fluency because then students can tell you all of the different either addition and subtraction facts that they see or all the different multiplication and division facts that they see. I've also been doing a lot of stuff with angles. So this is a protractor that can move around on the screen and I can move it any direction. So we can measure all of the interior angles of this triangle to make sure that it is an acute triangle. My sixth tip is use virtual manipulatives. There used to be a really good set of virtual manipulatives available to teachers, and now it has just exploded. It's actually awesome. I'm so excited about all the virtual manipulatives that are coming out and are available, and most of them are free, which is even the better part. On the right-hand side is one of my favorites. This is a digital geoboard from the Math Learning Center. If you Google digital geoboard, for me, it's the first hit that comes up. It's great, and you can use this for lots of geometry and measurement tasks, as well as things related to fractions and decimals. On the right, this is a set from Toy Theater. They've got a tremendous number of math manipulatives available right now, all for free. This is for using tangrams. So a lot of us think about putting these tangrams and making a square, but they also have all of these different shapes up there. At the top, I see a camel and a shark and a rocket, and then students can figure out how to use the 7 tangram shapes to make those different creatures or things. Here's another example from Toy Theater on the left-hand side. These are fraction tiles. There's quite a few fraction tile virtual manipulatives out there. I just like these because they're free, and they are colorful, and they're pretty similar to the colors if you have a hands-on set of fraction tiles, so that students can see the similarities between the hands-on tools and the virtual tools. And then on the right-hand side is an example of the Cuisenaire rods. Here we are just showing the example of the fraction 3/7, but you can do tons of work with the Cuisenaire rods with counting, with all of the operations. You can also do a lot of building here and thinking about what's the area of this shape, what's the perimeter of this shape. So really the Cuisenaire rods really are pretty almost limitless in terms of their usage. And there are hundreds of other virtual manipulatives available. You just have to usually find them. And I found a lot of really great websites where teachers have put together sets of virtual manipulatives. I've done this for my class that I teach at the University of Texas, where our class is adding, putting into a Google Doc all of the virtual manipulatives that are available. So if you want that, I'll share my email at the end and you can email me. Another great resource that I've been using a lot is Google Jamboard. This is free to people that have access to the G Suite, which I think is most schools and most teachers. Here was an activity where I was just having my nephews sort shapes, which triangles are acute, obtuse, and right. You just send the link to the Google Jamboard in the chat. It opens right up, and then they can drag all of these shapes around, or they could drag the acute name over a triangle, and you can see all of that. I've done a lot of this also with categorizing word problems by their schema. So which word problem is a total problem? Which word problem is a difference problem? There's just a lot of really cool possibilities with the Google Jamboard, and it's very, very easy to use, which I appreciate as well. The eighth tip for remote learning is to really incorporate mathematics that's related to students' real life and things that they want to learn. Again, this is a suggestion that we should always be doing, but think when students are working at home and they're not getting as much peer interaction as they normally would in their math class, and as not as much interaction with you, really learning, hey, what are you doing? What are you playing with? You know, what are you reading? And then incorporating those things into the math lessons is going to keep the students engaged in these in the mathematics intervention. On the left is an example. If you ever wanted to know what was packed on the Titanic before it sank, I found this information and was able to do math problems for days about the sugar and the tea and how much the captain made, and that type of thing. And then on the right, probably a lot of you might notice that that is one of the beginning creatures for the game Roblox. My nephews are really into that game, and so we were adding and subtracting numbers on a number line using this Roblox creature, and how that was so exciting and much better than using maybe just a bear or a picture of a dinosaur or something like that. The ninth tip is really getting frequent feedback through conversation. I've been doing polls with my nephews. That sounds so silly, but they think that's really fun. Rate today's work on a scale of 1 to 5. There's a little poll function that we can use in Zoom that is very, very easy to use and very fun to use. Thumbs up, thumbs down, visuals are really great to use, as well as the chat box. If students are a little bit older, I have found that the chat box is a really good way to communicate, and students find it very fun chatting in the chat box. And then the 10th tip here for remote learning is really collecting data and then altering the trajectory of your critical content or altering your instructional platform based on that data. So you can be collecting informal data from discussions, conversations, also just from watching students do math, and doing a lot of error analyses, like what was the mistake in that problem, and how could I teach that problem better tomorrow? You could also be collecting formal data. This is going to be an important consideration if your school or district is really still thinking about how to use MTSS in remote environments, which we hope that you are. So what is the role of diagnostic assessments? There's a lot of diagnostic assessments in math that are available online. So a student could do that online, and then you could use that data to inform which content students need to work on and then how you're going to teach that content. You should be collecting progress monitoring data in targeted and intensive intervention. Again, a lot of these formative assessments are already available online, so hopefully you have access to them. If not, I've worked with some teachers, like in New York City, for example, where they have taken their paper and pencil formative assessments and they're now doing those with their students via Google Meet. So they're actually showing the assessments and asking the students to answer the questions orally. That's one workaround that they've found that works for them because they don't have access to an online formative assessment. And then also summative assessments, if your district is doing anything with still fall, winter, and spring benchmarking, using that assessment data to drive what's in your targeted and intensive intervention. So in summary, when you are providing mathematics intervention, whether it's in person or remote, you really need to think about the design. So that's the critical content, the evidence-based practices, and then the instructional platform. And then you need to think about your delivery. So that's how are you going to use explicit instruction paired with precise mathematical language? How are you going to use multiple representations? How will you build fluency? And how will you provide problem-solving instruction? As I said, there's a few resources that I thought I would share before we close and open it up to questions. Both of these are from the National Center on Intensive Intervention. Here is the mathematics strategies to support intensifying intervention. And if you look toward the bottom, they've broken this down into 6 different essential skills where students typically experience difficulty. If you click on place value concepts, you'll find different lessons and materials to use to help students understand place value concepts. And there's also a lot of different videos that you can watch. And you might recognize the voice. I did a lot of those videos. Also on the NCII is this awesome resource called the Intensive Intervention in Mathematics course. You can find this by going to Implementation Support on the NCII website. You can also find this by going to your favorite search engine and type in NCII Math Course, and it's the first hit that comes up. But here what we've done is we developed 8 modules related to how to design and deliver intensive intervention. And I put these modules together, so it is a lot of me, but I do hope the information is very helpful to you. But module 1 is all about how to figure out the critical content for teaching. So we talked about that today. Module 2 is about how to use assessments in intensive interventions. We talked briefly about that. Module 3 is about how to find evidence-based practices. Module 4 is about using explicit instruction and multiple representations. We talked about that. Module 5, which I'll pause right there. Module 5 is where you can find over an hour about effective word problem solving instruction. So if you wanted to know more about those schemas that I was talking about and about word problem attack strategies, those are in Module 5, Part 2. Module 5, Part 1 is about building fluency, which is just as important as well. And then Module 6 and 7 deep dive into whole numbers and rational numbers respectively. And then Module 8 puts it all together. But this is all information that's there. There's over 20 hours of video that you can access. There's presentations that you can read through and share with other teachers, as well as a bunch of different handouts. So I hope you will access this information. It's pretty much everything we talked about today, just in an expanded form. And then if you have other questions or comments, I provide my email address here. Please email me, reach out, and talk to me at any time, anything about math. I just love talking about math intervention and math learning and math teaching. And then if you do want more information about the TIER project, please feel free to email us at tier@meadowcenter.org, and we will respond to you as quick as we possibly can. And so that's all for this webinar about mathematics and remote learning sessions. This is brought to you by the TIER project. That's one of the 9 networks funded by the Texas Education Agency. And TIER is housed within the Meadows Center for Preventing Educational Risk, as well as the University of Texas at Austin. So I thank you so much for joining in today, and then I'll turn it back to Burnett to see if any questions have come in during the webinar. Thank you so much for attending.
Hi, Sarah. Thank you so much. That was amazing. I wish you could have seen the feedback in the questions box. Lots of people
Oh,
appreciate everything that you've
I
provided.
don't see the feedback,
I
so
know.
thanks for telling me.
You don't get that immediate feedback that you were just speaking about, unfortunately. But yeah, everyone is very excited about what you've provided, the resources that you've provided as well. In addition to one question, where
Okay.
can we get a progression of the critical content? So where can we locate that?
If that person emails me, I can send you some resources. I usually use national resources related to critical content, and I can't tell you what that national resource is on this webinar. But I have found some webinars with, or not some webinars, I have found some resources within the state of Texas from specific school districts where they have worked on mapping out the TEKS by taking like the grade level TEKS and then putting them on a continuum. So I'm happy to share some of those resources. I will also say that many times it just involves sitting down for an hour or two, taking that maybe you're teaching 4th grade. So you look at the 4th grade TEKS, and then you have to look at the 3rd grade TEKS, and you have to look at the 2nd grade TEKS, and sometimes the 1st grade TEKS. And then I also think it's always important to look ahead. So take the 5th grade TEKS as well. And what's critical? And really the critical strands that you want to develop proficiency with your students in are related to number and operations, and then secondary is geometry. And so really thinking about, well, what are the standards really related to number and operations where my students need to develop that proficiency? And then looking at like your readiness standards versus your supporting standards, that's going to also be helpful with your decision making as well.
Thank you so much. I think that's really helpful. And again, as you stated, if they were to reach out via your
Yeah.
email,
Oh, I can send plenty of resources their
yeah,
way.
we had a couple other people that probably caught the end of you explaining that. And so, also, you all, at the top of your screen, you should have a button that says screenshot, and you should be able to take a screenshot of what is on your screen currently right now, what we are projecting for you to see. And that also can be, it usually goes to your desktop. It's saved to your desktop if you want to do that as well, for those email links. Again, Sarah, thank you so much. Next week, we will have a shift to literacy, and so our remote learning environment sessions will continue. Our series will continue, and deep dive into reading intervention within our remote learning environments. That will be relayed by Dr. Thea Woodruff. So super excited about that. And again, we will be here Wednesday at 9 o'clock. If you have not registered for that event, please feel free to do so. We would love to have you. For those of you that are returning, thank you for joining us again. Those of you that are new, thank you so much for joining us, and we hope we see you in our upcoming webinar session. That being said, thank you all for coming, and I hope that if you have any further questions, like Sarah said, please reach out to us, and we will gladly steer you in the right direction and get you what you need. So we will see you
Thank you.
next
All
time. Thank you all.
right. Have a good day.
You too.